Today, our video is on operations on functions. We're going to look at functions f of x equals, let's see, 5 square root of x, g of x equals negative 8 square root of x. We are going to look at a little bit of different notation. We've already added 5 square root x and negative 8 square root of x. We've already done these things. Now we're going to look at different operations. So first we're going to look at adding and subtracting. Our notation is going to be a little bit different. It's going to say f plus g of x. This means add f of x to g of x. So that means 5 square root of x plus negative 8 square root of x, which is negative 3 square root x. Remember, we're just adding up how many square root x's we have. 5 minus 8 is negative 3. If I have f minus g of x, this means subtract f of x minus g of x. So that's 5 square root of x minus negative 8 square root of x. Minus a negative becomes plus the positive, so we get 13 square root x. And then the book is going to ask you state the domain and evaluate the sum when x equals 16. Okay, so it says state the domain and evaluate when x equals 16. So our domain for both addition and subtraction has to deal with the square root of x. Remember that the square root of x, we know that x must be greater than or equal to 0. We can't put negative 4 under the square root of x and get a real number. And so our domain, there's numbers that have to be greater than or equal to 0. And when x equals 16, negative 3 times the square root of 16 is negative 3 times 4, which is negative 12. And then 13 times the square root of 16 is positive 13 times the square root of 16 is 4, which is 52. So it's just asking you to add them together and subtract them. We've done this before in many different ways. We are just looking now at different notation. Let's try polynomials. Let's let f of x equal 2x cubed plus 4x squared minus 8x plus 4. And we'll let g of x equal 3x cubed minus 5x squared plus 6x minus 9. So if we're asked to find f plus g of x, we're adding them together. 2x cubed plus 4x squared minus 8x plus 4 plus the 3x squared minus 5x squared plus 6x minus 9. This is a cubed. So I get 2x cubed plus 3x cubed is 5x cubed minus 4x squared minus 5x squared is minus 1x squared. Negative 8x plus 6x is minus 2x, and 4 plus negative 9 is minus 5. So f plus g of x is this polynomial. The domain of these polynomials are all real numbers. I can plug anything into a polynomial, so the domain is always all real numbers on a polynomial. And then if it asks you to find, evaluate when x equals negative 1, we plug it in. Could we use synthetic substitution on this? Ooh, that's a nice little way of doing that. We could either plug in negative 1 for all the x's, or we can use synthetic substitution, a nice little reminder. Remember, we write down our coefficients, 5, negative 1, negative 2, negative 5, and then we put a line in between the 2 and the negative 5 under our line. We bring down the 5. 5 times negative 1 is negative 5. Negative 1 plus negative 5 is negative 6. Negative 6 times negative 1 is positive 6. Negative 2 plus 6 is 4. 4 times -1 is -4, and -5 times -4 is -9. So f plus g of -1, that would be our notation, meaning plug -1 into the sum is equal to -9. And you should get the same answer if you did 5 times -1 cubed minus -1 squared minus 2 times -1 minus 5. This becomes -5, and that's +1, so -1 plus 2 minus 5. -6 plus 2 minus 5. -4 minus 5 is -9. So see how we get the same answer with synthetic division, or substitution, and direct substitution. Now if it asked for f minus g of x, we're subtracting. 2x cubed, and whatever is first is what we're subtracting. If it said g minus f, I would put g first. 2x cubed plus 4x squared minus 8x plus 4 minus the whole thing, 3x cubed minus 5x squared plus 6x minus 9. When it's subtraction, we change it to plus the opposite. So I like to go in and change all the signs. So remember, I'm subtracting, so minus that positive minus the negative becomes plus. Now I get -x cubed plus 9x squared minus 14x plus 13. And then again, the domain is all real numbers. And what do I get when I plug in -1? Well, my coefficients are -1, 9, -14, and 13. -1, 1, 10, -10, -24. There's my line, +24, and 37. You should get the same thing if you do the direct substitution as well. Now we're going to look at multiplying. And dividing. So if we are asked, it's going to look like, let's let f of x equal x cubed and g of x equal the square root of x. If it's asking fg of x, or f times g with a dot of x, it's asking us to multiply f of x and g of x. So in this case, it's x cubed times the square root of x, which we can't do much other than write it as x cubed square root x. Or if I wanted to write it as x cubed times x to the 1/2 power, I can make that 3 and 1/2, make that improper. 3 times 2 is 6 plus 1 is 7, so x to the 7/2. Okay, my domain, because I have the square root of x in there, is x must be greater than or equal to 0. And if we're going to evaluate when x equals 4, so x to the 7/2 power means the square root of 4 all to the 7th. The square root of 4 is 2. 2 to the 7th is 128. That's fg of 4. And what about dividing? F over g of x means to divide f of x by g of x. And here's a situation where it might be easier to look at this in terms of, there's my puppy, x cubed divided by the square root of x. We might want to write that as x to the 1/2 power. And then I could subtract. 3 is 6/2, right? 3 over 1 times by 2 times by 2. So I get 6/2 minus 1/2 is x to the 5/2. So again, because this represents the square root of x to the 5th, my domain is x is greater than or equal to 0. When I plug in 4 to the 5th power, square root of 4 to the 5th is 2 to the 5th, which is 32.